Hello everyone, my name is Chesanek, and for my final project I will be talking about case hardening. Now what is case hardening? Case hardening is the process of taking low carbon steel and exposing it to an environment that is rich in carbon and or nitrogen atoms and diffusing them into the steel to strengthen it. This results in the outer layers of the steel having a much larger carbon or nitrogen content while the inner layers remain largely unchanged. Case hardening is often used when a product only requires external strength instead of overall strength, such as for steel files, bolts, and gears. There are many types of case hardening, which include, but are not limited to, carburizing, which uses a carbon-rich gas for hardening, cyaniding, which uses a cyanide-based salt to add carbon and nitrogen to the steel, carbonitriding, which uses a rich ammonia gas to also add carbon and nitrogen to the steel, and then heating and quenching, which is the process of rapidly heating and then cooling the steel by quenching it to alter the carbon and iron structure of the steel. It is typically only useful though if the carbon content is high enough, roughly about greater than 0.3% by weight, and as such is normally used alongside other hardening methods such as carburizing to yield more favorable results. As depicted by the photo on the right, the steel is placed into a sealed chamber which is then filled with a carbon-rich gas at high temperatures. One method for this, although a bit outdated, is to burn coke fuel as a method of both providing the heat and the carbon for the steel. Then, after the calculated time has passed, the steel is then removed and quenched in either oils or gases to finish the hardening process. This process takes low carbon steel with a carbon content of about 0.2% by weight and increases the content around the exterior to about 0.8% by weight. The depth of the carbon diffusion varies from part to part based on the needs of the part as well as the size, but is often anywhere from 0.1 millimeters to 5 millimeters deep. While the time it takes for the process to complete is dependent on the temperature, the process is often done around 900 to 950 degrees Celsius, as going higher to increase the speed of the process can often result in a weaker product when compared to products made at the standard temperature. The diagram on the right depicts the steel surface in contact with the carbon-rich environment. As you can see, the smaller orange carbon atoms are present interstitially between the iron atoms, thus indicating it as a steel structure with a low carbon content. Over the calculated time, the carbon will diffuse into the steel to harden the exterior, but will only travel so far due to the limited time within the chamber. The time required to diffuse the carbon into the steel can be calculated using the diffusion coefficient at 950 degrees Celsius, the depth required, and the required concentration by using Fick's second law for the non-steady state diffusion. Now, why would you case harden steel? Case hardening is considerably less expensive than through hardening the steel. As previously stated, sometimes only exterior strength is needed for some tools. There is also the issue that certain tools may not be available in the sizes needed when through hardened. Case hardening allows you to take a more available low carbon steel tool and case harden it for the job that you need it for. There is also the case that sometimes both the hardened and unhardened properties of steel would both be useful, and as such case hardening would be better than through hardening or not hardening it at all. This brings me to the end of my presentation on the process and uses of case hardening. Thank you for listening.